Hey everyone, and welcome to The Explainer. So if you're a computer science student trying to get your head around the foundations of distributed systems, you are in exactly the right place. Today, we're jumping into the world of Hadoop, a technology that totally changed the game for handling data on a massive scale. All right, we're about to dive deep into the architecture and the core ideas behind what was a truly revolutionary framework for big data. Let's get into what happens when the amount of information you have gets so huge that your traditional systems just can't keep up. So here's what we're covering. First, we'll look at the problem that made Hadoop necessary in the first place. Then, we're going to break down its two main components, HDFS for storage and MapReduce for processing. And finally, we'll get a peek at the incredible ecosystem that was built right on top of it. Let's start with the big why. So let's rewind to the early 2000s. You've got these giants, right? Yahoo, Google, and they're facing a problem that's just massive. They were collecting an insane amount of data. Web crawls, searches, clicks. And the problem wasn't just where to put it all, it was how to make any sense of it.
And that brings us to the core engineering question they were wrestling with. Your classic databases? Way too expensive, and they just couldn't scale to handle petabytes of information. The answer couldn't be some single giant supercomputer, no way. It had to be something new, something that was distributed and built on hardware you could actually afford.
And this is the solution that came out of all that. Hadoop is a framework that lets you take a whole bunch of commodity hardware, we're talking regular, off-the-shelf servers, nothing fancy, and link them together so they act like one giant, powerful system. It was basically a super clever way to get supercomputer power on the cheap.
Okay, so how on earth does Hadoop actually handle all that data? Well, it all starts with its special storage system called HDFS, the Hadoop Distributed File System. You can think of this as the absolute bedrock that everything else is built on.
This quote really just nails it. It's versatile because honestly, it doesn't care what kind of data you throw at it. It's resilient because it's designed from the ground up to expect and handle hardware failures. And clustered, of course, because it works across a whole fleet of machines, not just one.
You know, when you look under the hood, the architecture is actually pretty simple. It's a classic master-slave setup. You've got one master server, the NameNode, which is kind of the boss of the whole operation. And then you have lots of slave servers, the DataNodes, that do all the heavy lifting of actually storing the data.
A really great way to picture this is to think of a library. The NameNode is like the MasterCard catalog. Now, it doesn't hold any of the books itself, but it knows exactly where every single one is. The DataNodes, well, they're the bookshelves. They're the ones actually storing all the information.
And this division of labor is absolutely crucial. Think of the NameNode as the brain, the manager of the whole operation. It keeps track of all the metadata, like file names, permissions, and the location of every single chunk of data. The data nodes are the muscle. Their job is simple: store the data blocks and constantly check in with the NameNode, sending these little heartbeat messages to say, yep, I'm still here, I'm healthy.
Okay, so we've got the what HDFS is, but the how. How does it handle these enormous files? And more importantly, survive a server just, dying? Well, the magic is all in the mechanics of how it stores data.
All right, here's the breakdown. First, HDFS takes these massive files and wham, chops them up into big, chunky blocks, like 128 or 256 megs each. Then, for safety, it makes copies or replicas of every single block and scatters them across different machines. It's even rack-aware, which is super smart. It means it tries to put copies on servers in totally different physical racks. Why? So if an entire rack loses power, no sweat, your data is still safe somewhere else. And if a data node just stops sending its heartbeat, the NameNode just goes, okay, that one's gone, and automatically creates a new copy of its blocks on another healthy node.
But, just storing all this data, that's only half the story, right? The real point is to do something with it. And that brings us to Hadoop's computational engine, MapReduce. This is the part of the system that actually analyzes all that data sitting in HDFS.
So MapReduce, it's this awesome programming model built around a super powerful idea: divide and conquer. You take a gigantic computational task, you shatter it into a ton of smaller pieces, you have the whole cluster work on those pieces all at the same time, and then you cleverly combine all the results back together at the end.
Okay, so let's walk through how a MapReduce job actually works. After your data gets split up, the map phase kicks off on hundreds, maybe thousands of machines at once. Each one runs the same function on its little piece of data, spitting out key value pairs. Then, the framework automatically does this shuffle and sort phase where it gathers up all those pairs and groups them together by their key. Finally, the reduce phase comes in, takes each group of values and does some kind of aggregation, like counting or summing, to get your final answer. That result then gets written right back out to HDFS.
Now, HDFS and MapReduce, they're the absolute core, the two pillars of Hadoop. But let's be honest, working with them directly can be kind of tough. And that's exactly why this huge ecosystem of other tools and technologies popped up around them, all designed to make big data processing easier and way more powerful.
For instance, writing complex MapReduce jobs in Java, it was hard and it was slow. So that's where tools like Pig and Hive came in. Pig gave you a simpler scripting language, but Hive was a total game changer. It let anyone who knew SQL query petabytes of data without writing a single line of Java code. Then there was Yarn, which became the new brain for managing cluster resources way more flexibly than the original MapReduce could. And for getting real-time random access to data, something HDFS is terrible at, HBase was built on top of it, acting like a giant, non-relational database. Finally, you needed a way to get data in and out, so tools like Scoop were built to be the bridges between Hadoop and all those traditional databases.
This entire ecosystem, it's what turned Hadoop from just a specialized tool into a full-blown data platform. And each piece we just mentioned, Yarn, HBase, Hive, is a huge topic all on its own. So that leaves us with a pretty big question, doesn't it? How did these technologies actually work? And how did they set the stage for the data tools we're all using today? Well, that's exactly what we're going to dig into next time. Thanks for joining this explainer.